so yeah. So the main problem is that people are keep coming till like after 1 hour and 1.5 hours. So that is the problem. It's not possible to go through same thing again and again. So maybe, so it's just a request. So try to come at least like maybe by 6:05 or 6, max 6:10. So wait for some 2-3 minutes. People are keep coming. So. So okay, so it's already 6:05. So let's start with some basic discussion. Okay, so I'm going to share my screen. So I hope the screen is visible. If yes, just any one of you just write yes in the comment box. Okay, thank you. Okay, so let's start with the week 2 thing. So basically, so you have already learned about this Levenstein distance between. Uh, so when you have a word and if the word is misspelled, then you need to rectify the word. So before rectifying the word, so people are keep coming. Okay, so the first thing that we will discuss is the spelling correction. Okay, so the spelling correction thing. So what the thing is that suppose you have the word W and you misspelled it W star. Okay. Now how to the first thing is that you need to identify. So the first step is that detection. Okay, so you need to detect the thing and then rectify. So this is the step. So for detection, the simple thing is that, so I think the PG sir also taught that in the class. So for detection, what you need to do is that search the thing in a dictionary. If this is in the dictionary, then the word may be fine. No, it's not like that. It is fine because, like, suppose you are if suppose this is your intended word, but you are typing TO, both these two words are correct. Okay, so this is your gold standard word and you are typing it like this thing. Both these things are correct. Now if you are going for a dictionary search, you will find this word in the dictionary too, but that does not mean that this word is correctly spelled. So for the time being, just think like these things, like this thing is a special case. So most of the time what we do, like suppose we want to suppose this is the world. So suppose this world is a word that we want to spell, but sometimes we misspelled it like world. So this kind of thing we can catch by checking with the dictionary. So this kind of word we cannot find in dictionary. So this is the first step to detect. Okay, so this is a spelling error. Now the next step is that, so how will we rectify it? So suppose I write it word, so what is nearest matching correct word? Okay, so for that what we need to do, first we need to set up a candidate set. Okay, so suppose we write, suppose in a essay we write word WRLD, so it's a like incorrect spelling. Now to rectify it, first I need to find what is it candidate set. So candidate set basically, so what can be its possible correct version. So there may be multiple, like infinite number of word can be its candidate set. But if you follow the lecture correctly, in that lecture Prof already discussed that like most of the error come from like one or two like error distances. Is it correct or not? So most of the error are coming from one or two 11th distance. So basically, if world is a correct word, then its most probable misspellings are maybe one word deletion, maybe one word insertion, some kind of thing. So just one word distance from the correct thing. So if we go in this statistics, with these statistics, so just one word 11th distance apart, the correct word and the misspelled word, then we will find a like set of gold word for this thing. And then suppose this world one, W1, W2, W3, so W5, so those 5 words are correct correct candidate set for this erroneous word. Then we can find the 11th distance from each one of them and take the smallest one as like the correct solution. But this is without any context, without seeing the context. Okay, so this is just to standalone error correction. So given a word, rectify the like correct the word, but without any seeing the context. So maybe in the sentence there are multiple other words before and after the words, but we are not considering the context to rectify it. We are just standalone rectify the thing. So the first question is related to that. So in the slide also, in this lecture slide also, I think the prof discussing about this insertion and deletion thing. So we have a word insertion and I want to go to deletion, and so there are multiple cost involved. So for insertion the cost is 1, deletion is 1, and substitution is 2. So okay, so let's again so give a recap for that. So suppose this is my word. Okay, so this is a word and I want to go to this word, and this word is length of suppose n, and this is length of n. So the distance between I comma j, so there can be multiple possibilities. Okay, so one thing is that we can take then plus 1. This is one of the possibilities. Then I minus j minus 1. So basically this is a dynamic programming problem, or maybe we can go vertically, and then this value is variable. So if x maybe I equal to y j, then it is 0. Okay, else it is 2. Okay, so this value is 2 if these two are not similar. So and we are taking the mean of this thing. So this is the prime. So this is just to revision. This is the thing. So this yeah. So suppose this is the x thing, so dot, and this is the y thing, dot, and we know till this point. So this is, suppose this is yeah. So suppose this is I minus 1, this is j minus 1. Now I want to check what is the distance for this with this and till this point. So to check this thing, we have multiple possibilities. We can check this with this one, or maybe this with this one, or maybe this thing. So this is the basic thing. Now yeah, so okay, so if we made a table for this thing, so in the bottom we are writing deletion, and in the row in the row we are writing this this insertion part. So we want to go from insertion to deletion. No, this is not the case. So now first we need to fill this thing. So yeah, so the row thing. So what does the first row mean? So the first row simply mean is that, so we want, like, this is a blank thing, so has like this has so from null I want to go to D. So basically, so then we need to go for one insertion. So there is no value, no character there, and I want to go to D. So this was just 1. So the cost, this is the insertion, we need to insert D, so that's why the cost is 1. To null it is 0, and if we null to E is 2, because we need to D and E, we need to insert D and E, so it is 2, and it is like till n we need to insert n value. Similarly, if we go to the column thing, so from I need to go to the null, so we need to delete I, so that's why the single operation is there, so 1 is there. Similarly, if I so I N S E, so till, so suppose we want to get like from E we want to go to the null string, so then we need to delete this 4 thing, so I N S E, so that's why it is 4. So this is the basic setup. So we need to fill up this first row and first column with this value, and then okay, and then what we need to do is that, like, next thing is that we need to calculate the value of this position. This is the I and J position. So basically we need to take care, okay, so this 3 value, so 1 0 and 1, so minimum of these two, is it 1 plus 1? No, basically no, we are going for this first one, second one, third one. So next week we will discuss the third week. So basically this class and this session is not aligned. Okay, so basically this is class is, if the class is T, maybe this is T minus 1. So this is the, okay. uh, so then we need to go forward like this one. So take the minimum of these 3 cell. So this 1 plus 1 is 2, and this 0 2 here, because I and D is not same, so this 0 plus 2, and this is 1 plus 1, so all these values are 2. So the minimum of this thing will be, so 2. So in this way we'll go forward and calculate the values. Okay, so this is a big problem. So I just request you to go do this thing. So suppose we want to find the distance between dogs and cats. This is a small thing, so can you do it here, and we'll then, if you have any doubt, so give me the answer. So what is the distance between dogs and cats? Okay, so do it here. So I hope you know how to do this thing, because these things are already covered in the class. So okay, so let's do step by step. So you want to go from dogs to cats. So let's draw the table here. So this is cats. So let's write in capital. Slash. So what is the first step? We need to fill this row. This one and this one. Okay, this one and this one. So this thing will be 0. Okay, then 1, then 2, then 3, 4. Similarly, this also 1 and 2 and 3 and then 4. Okay. Now, how will we calculate this row? How will so this will be, suppose, so we need to calculate this one. So we need to calculate this one. So basically, what will be this value? So it will be a mean of these 3. Okay, so it can be from 1. So this can be 1 plus 1, or 0 plus 0 means this one. So 0 plus will it be 0 plus 0 or 0 plus 2? So it will be 0 plus 2 because D and C is not same. So it will be 0 plus 2 and this thing. So from this one. So 1 plus 1. So all these things are 2. So minimum of this thing is 2. Similarly, if we go, it will be 3, it will be 4, it will be 5. Similarly, if you fill this thing, it will be 3, 4, 5, 6. Again, it will be 4. This will be 5. This will be 6. This will be 7. This will be 5, 6. This will be 7. Now, if we calculate this thing, so what will be the mean? Mean equal to 7 plus 1 or 6 plus 0, because S and this S are same. So it will be 6 plus 6 and 7 plus 1. So 8, 6. So mean. So it will be 6. Okay. So you get the idea. So basically the distance from dogs to cats is 6. But how, if we want to know how these things are, like how if we want to go from dogs to cats, how it says. So then you need to backtrack. Okay, so then you need to backtrack. So basically, if we backtrack, so from so when you came here, like so this 6 is coming from this one. Okay. Similarly, this 6 is can be like it can be from here also, because like for all this thing it will be 6. So maybe we'll decide, okay, so if this is the kind of like ambiguity, this is not ambiguity, so this kind of multiple possibility can happen, then we will always go for maybe this diagonal one. So you can decide all these things, and if you backtrack this thing, you will so we will backtrack this thing, we will get the value. So so if we draw the diagram, so basically this is DOGS and cats. So these two are similar, so there is no cost involved. But for each of these 3 elements, we need to substitute. Okay, so we need to substitute O by A, G by T, N by D, and the cost for all this operation is 3. So there are 3 operations, and for all these things, substitution cost is 3. So basically this is 6. So that's why this value is 6. Okay, so you can see these things from like from other direction also. So you are not doing the substitution operation, you are doing one deletion and then one insertion. So basically again it involves 2, the cost of 2, one deletion and one insertion. So you are deleting D and you are inserting C. So again, if you go in that way, you will again find the cost is 6. So these things, so this is the small baby example, and this is the large example, but the concept is same. So you are just filling the values and ultimately the corner is, yeah, you will get the right answer is 7. Yeah, for in our case the right answer is 6. I think in the chat someone also is writing 6, so good. Yeah, you are doing it right. So, yeah. And from this thing you can backtrack to see the see the ultimate thing, so how these things are working. So how, so in which value are in which cell we are doing the deletion, in which cell we are doing the insertion, and you just need to trace the, you just need to trace the value. Okay, and then you will find all this. So if you trace the value, so basically this will be the answer. So just, so basically what is the thing? So basically insertion, and here the deletion, DION, deletion. Oh, sorry, I might have missed something. In insertion, is that, yeah, sorry. There will be a blank, and this thing. So basically these two, these two, these two, these two, these two. Yeah. Sorry, this I totally write it wrong. So basically this is I, then N, then S, then E, then star, then R, then T, then I, then O, then N, and here is T, I, O, N, and this thing is deletion. So these are substitution operation, but with zero cost. But this substitution, this is a substitution with cost 2. This is a deletion operation with cost 1. This is zero cost substitution. This is 2 cost substitution. This is a deletion. This is also deletion. So total 1, 1, 2, 4, 5, 2, 7. So total 7. This cost are 0. If you trail the value, you will find this pattern. Okay. Okay. Now come to the next part. So this is about this language modeling. Okay. So suppose, I hope you already know what is language modeling. So basically, given the language modeling thing. So we have a string. Suppose this is the sentence. So it consists w1, w2, ... wn. And if I need to predict the probability of this word, so if I don't go for any context thing, so we can just then find the probability of this word. What is the probability of probability of this w2 without seeing any of the context? Okay, without any of the context. So basically, then how will you find this kind of probability? So then you have to have some corpus. Suppose someone give you a large corpus. In the corpus there are multiple sentences, and each of the sentences consists of multiple words. And if you go through each of them, you will study the probability of each of these things. So suppose w2 happens to appear in the whole corpus 500 times, and in the total corpus vocabulary is maybe 10,000. So then you will get the probability of PW2. So this is the without seeing any of the context. Okay, so you are just saying the probability of this W2. But in the language model, so this is kind of a unigram language model. So you are not saying any of the previous context. So this is kind of unigram. Now, for biogram, what we are doing? So we are just saying, okay, so what is the probability of W2 given W1? So we are considering that W1 is already happened. Now tell me what is the probability of. So if I go with the chain rule, what is the probability? So basically we need to yeah, so I'm just writing it wrong. So this is the probability. So basically this is the thing. So what is the probability of the string W1 comma W2? So first W1 have occurred, and then what is the probability of W2? So this is a biogram thing. So we are seeing just previous one character before this thing. So this is a biogram thing. Triagram thing, we just need to see the last two character. So basically if it's the n-gram thing, then we are just seeing previous n minus 1 character. Previous n minus 1 characters to predict the n character. So this is the simple concept. Now in this question, what they are asking is that what is the total count of unique biogram for which the likelihood will be estimated. Okay, so basically in that part they are just asking, so tell us what is the unique biogram in this three sentences. Suppose this is a corpus. So Alice, so in the corpus there are only three sentences. So Alice went to cafe, Bob was waiting for Alice, and Alice and Bob went to the museum. So these are the three sentences, and the assumption is that there is no pre-processing. So pre-processing means that, like in the last week also already discussed, there are multiple pre-processing that can happen into the corpus. So basically we can go for normalization, lemmatization, steaming, all these things. So for simplicity purpose, so they are assuming there are no such kind of operation are going to happen in this corpus. Just there are these sentences and tell us the unique biogram. Okay, someone is saying voice is very low. Is it everyone, for everyone, is it low? Yeah, it's okay. Yeah, thank you. Okay. It's okay. Okay, so can you just do it? It's a very small corpus. Can you just give me the number of unique biogram for this? Yeah, so before doing that thing, so just a clarification. So suppose I have a corpus with just two sentences. I love India, and I also love maybe Germany. Okay. So basically in the corpus there are only two sentences. So before going to this biogram thing, you just need to add, I think in the lecture you also see this thing. So there is a start tag and there is a end tag. So each of this sentence should like start with those two tag and close with this tag. Now we need to find the different biogram. So for this corpus, what is the different biogram? So first thing is this thing. Yeah. So SI, then I love, then love India, then India. Yeah. Then again SI. I also love Germany, and okay. So these are the different biograms in your corpus. Yeah, in your corpus. But if you see this and this, these two are repeating. So there is a common thing. Is there any other thing? Is there any other diagram repeating? I guess no. Yeah. So then how many total unique diagram are there? So total diagram are 1, 2, 3, 4, 5, 6, 7, 8, 9. So among 9 there one is common. So basically 8 unique diagram is there. So similarly for this question, if you go through this thing, so remember to include those two tag, and then yeah, I will explain the diagram also, don't worry. So diagram just extension of the diagram. Okay, so this thing, so for this diagram thing, how will see this thing? So this is like the S allies this task manager, and then if you go over, then ON2, all these things are there. Okay, so all these things are there. So there are this many diagrams are there, and among this there will be some of them repeating, maybe. Yeah, just check. Okay, so this allies, so this allies and ON2 and to the above, these are repeating, so total diagram is 70. So till now it's okay. Now yeah, so the diagram thing is basically same. So diagram thing is basically same thing. I hope you know the concept, but I hope you have some doubts about the question, assignment question, and all these things. So just to clarification, so suppose this is your sentence with the n words, and if you want to predict W3, then you are just taking the like you want to consider these two values, this W1 and W2 also. So W1 and W2 also. So to calculate the probability of W3, you also need to consider this W1 and W2. So basically, suppose if this is the thing, so what is the probability of this whole string? If we go with this diagram model, so then basically this is P1. So before this W1 there is no things, no other words. So I'm just taking as it is. Then because like now for W3, so after like from W3, so all this thing will be like from this diagram thing, but before W3, as there are like only one words and single words, so we are just taking the single probability. So this is a unigram thing, this is the bigram thing. You can do it like this way. So to make a unigram thing, you are just what you can do is that just make two dummy character. Okay, so you can add some dummy character, maybe without any, just to get this thing. So for like you can just transfer it like W1 given hash double hash, okay. Then W2 given W1 single hash, and then it is as it is. So basically just to convert all the probabilities to a diagram probabilities. You can go with this one, you can go with this one also, but this is just to explain the thing. So basically all these things are a diagram model, but as before, like till W1 W2 there are no like just only two words, so we cannot go for diagram model. So we are just going for a unigram and then bigram, and from W3 we are just going for as it is for diagram thing. But if we like to maintain the consistency, you can just add two dummy character before the sentence, and you can write it as this way. There is no harm. Okay. Okay, so in the question they are asking, so the Markov model. So I hope you also know the Markov thing. So basically the Markov assumption is that basically the same thing. So if you have a sentence till Wn, so maybe this is Wi. So to predict Wi, yeah, so basically to predict Wi, you need to consider the previous till w1 to wi minus 1. Okay, so this is the thing. So actually I have written in the wrong way. So basically, to predict wi, you need you need to consider the last I minus 1 character. Okay, so this is a kind of I minus 1 Markov model. So if we are suppose this is k, okay, then if I like write it this way, w k plus 1. So this is a kth order Markov model. So basically you are seeing previous k character to predict the k plus 1 character. So this is a kth order Markov model. But in case of n-gram model, we predict so what is the connection between Markov model and this unigram thing? So for unigram thing, we are not seeing any previous character, so we are just seeing 0 previous character. For bigram thing, we are seeing just previous 1 character. For trigram thing, we are just seeing 2 character. Okay, so basically same thing. So I hope you get the idea. So basically for kth order Markov model is a k plus 1 bigram model. Okay, k plus 1 gram model. So bigram trigram. So k plus 1 gram model is basically is a kth order thing. Or you can say it other way around. So n gram model is a n minus 1 Markov model. Basically in n-gram model, what we will do? We see previous n minus 1 character. So in the n minus 1 Markov model also, we are just saying the last previous n minus 1 character to predict the. So basically this is the thing. So the question is that a trigram language model is a dash order Markov model. So what will be the answer? So n-gram Markov model n minus 1 Markov. So basically just minus 1. So trigram model will be a second order Markov model. So it will be a second order Markov model. So trigram is 3. So 3 minus 1 is second order. Yeah. So the answer is second. Yeah. By definition, n-gram language model is a n minus 1 order Markov model. So answer is. Now this is the thing. So there are 5. So Q5 to Q9. So there are 5 questions, and all of those questions are like based on this corpus. Okay, so what is the corpus? So there in the corpus there are 5 sentences, and yeah, so the sentences are already put in between those tags. So this start tag and end tag, so you don't need to put it explicitly, so they are already included. And the assumption is that this normalization is done. Yeah. So now let's see the first question. Okay, so the first question is related to this diagram thing. Okay. So the first question is related to the diagram thing. So what is the question? So they are asking, okay, so find the probability of Michael and Jack played at the playground. So how will you do that? The thing is pretty simple. So you need to just calculate all these different probabilities and get up the value. So so if you see this sentence, so I hope these questions are not in the assignment. Huh? Okay, so what is the thing? So Michael and Jack played at the playground. Probability of, so just for short I am just writing M, Michael and Jack, I am just writing J. Played at the playground. Played at the and we are closing it with. Now this is a triagram model. So what is the first thing? So first, because like this is a triagram model, so we can start the triagram model basically from here, because before that we don't have the value for the two characters. So for simplicity, just calculate the probability of this thing. So probability of this marker, then just chain rule, then given given this thing, what is the probability of m? So m is given is. Now we can start that with the diagram thing. So probability of and given is m, and go on, just go on. So probability of z, probability of z given m and dot till the last thing. So probability of given the playground. Okay. So this is the whole thing. So if you multiply all these values, you will get the probability of this sentence according to the diagram model. Okay, so now how will you get this individual probabilities? The thing is very simple. For this kind of unigram thing, you just need to count how many times this thing occurred divided by the total vocab. And similarly for this kind of thing, so how you will calculate? Suppose this is the thing. So you need to calculate the probability of and given start and then m. So m is like mag or so. I'm just shorting it. So then how will you calculate the probability? So it will be how many time count of basically start, then m, and then end, and then count of start, then end. This is the approximation. So how many time this start and m occur together, and then you also need to calculate so how many times this start and m followed by end. So then you need to divide, then you will get the probability for this. Similarly, you will get the probability for all this. So let's see how they have done this. Yeah. So first the thing is that so they are starting with this. They are just ignoring the star symbol, but ultimately they will add, like they will multiply. So just think. So first thing is that given the so this thing. So given the start, what is the probability of m? Okay. Given the start, what is the probability of m? So how they will calculate this thing? So because this star symbol occurred 5 times, and out of this 5, only single time this start is followed by Michael. So the probability of this thing is 1 by 5. Similarly, what is the probability of this thing? So how many times S and Michael occurred? So S and Michael occurred only once. And among them, how many times S and Michael followed, and is followed by S and Michael? This is also 1, the single case. So the probability for this is also 1. So such a way, if we calculate all this thing, we will get the value. Okay. Yeah. So till this symbol. So the playground. So the playground. How many times the playground occurred in the corpus? So I can see in the 4th sentence the playground, and also in the 3rd sentence at the beginning the playground. So twice this the playground diagram occurs, and among these two, only one time these two are followed by this end sentence tag. So the probability is 1 by 2. Okay. So the probability is 1 by 2. Now you just need to follow the chain rule. Just multiply all this probability. So that just multiply all the probability. So now you can see. So why they are not including this thing? So they are starting from there. So they are excluding this thing, because what is the probability of this thing? All these sentence are starting with probability of this thing. So this thing is 1. So the probability of PS is 1. So that's why they are ignoring that thing. So it is not like adding any value to the output. So if we go to this way, so you will get the probability 1 by 60. So if I go with a trigram language model, the probability of the sentence is this 60. Okay. Okay. Now, okay. So now the next question is the perplexity. So given the same language model, what is the perplexity of the sentence? So I hope you know the formula of the perplexity. The perplexity formula is quite simple. So the perplexity formula is quite simple. So okay, so perplexity of a sentence is the probability of the sentence. So suppose S is W1 to Wn. So the probability of the whole sentence normalized by is nth root, like how whatever 1 by input. So basically if we take this thing, so 1 by, so this minus will go down, so it will be this thing. And if we go to the chain rule, it will be 1 by summation of this, the whole thing. So probability of Wi given W1 to Wi minus 1. Yeah. So this is the perplexity. So what perplexity actually like tell us? So if you see the formula, so this is the denominator. So if the probability of a sentence is low, okay, so if the probability of a sentence is low, then the whole denominator is low. And if I divide 1 by a low score, then the perplexity will be high. So for a low confidence word, so low confidence sentence, the perplexity will be high. So it is high. So basically perplexity is inversely proportional, like basically it's inversely proportional with the confidence, or yeah, you can write the confidence of the sentence. So the thing is that how like how much confident the sentence is correct, or something like the probability of the sentence. Okay, so that basically this is the inversely proportional with the sentence probability. So if the sentence probability is low, then the perplexity is high. Okay. Now in the sentence, how will you calculate the thing? So the thing is pretty simple. So you already get the probability of the sentence is 1 by 60. Now formula of the perplexity is like 1 by this probability of this thing divided by 1 by n. N is the number of words. So in the sentence, how many words are there? So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 words. So in the sentence there are 9 words. So basically this will be 1 by 9. So 1 by 60, sorry, 1 by 60 to the power 1 by 9. You will calculate the value and get the, so it will be I don't know, it will be 1.576. Yeah. 1 by 60 to the power 1 by 9. So this is the perplexity. Okay. Now they are asking. Okay, so now what they are asking. So they are asking. So given the same language model, this time consider the Laplace smoothing. So in the Laplace smoothing, they are asking. So add one Laplace. So I guess you know why we need such kind of smoothing. Such kind of smoothing thing. What is the necessary for such kind of thing? So just to recap, suppose we have a corpus. So this is the corpus, and it has only two sentences. I love, same running example. I love India. I also love Germany. So this is the corpus, and from the corpus, obviously, you can calculate the, and suppose our language model is bigram. So we are going for the bigram language model. Now, suppose so this is the corpus, and now I want to check the probability of a new sentence. So the sentence is like I eat rice. Now if you see, so how will you calculate the probability of this sentence? So this will be the probability of I, then the probability of eat given I, and ultimately probability of rice given it. Now can you find any of the probability from this corpus? Yeah, you can find the probability of this thing because I is already there. But how will you find this two probability? Probability of eat given I, probability of rice given it. So basically, if we straightforward go with the previous formula, so the probability of eat given I is a count of I eat by count of I. You will found this is 0. There will be some value because in the corpus you will find I there, so there will be some value. But ultimately the probability of this thing will be 0. But as we are going with the multiplication thing, so the whole probability of the sentence will be 0. So this is the problem. So if we just straightforward go with this kind of count thing without any smoothing, we will like fall into this kind of trap. Okay, so you will fall in this kind of trap. So to avoid those things, so what people do? So people do various kind of smoothing. So they are so suppose if the same thing. So the probability of I eat given I. Now, so what is the thing? So this is the count of I given I eat. Now this thing is like previously 0 because in the corpus you cannot find anything I eat. So in that kind of situation, they are adding some kind of values, some kind of epsilon thing. So for this, for Laplace add one thing, so they are just adding 1 in the numerator, and the denominator they are adding with the number of vocabs they are having in this corpus. So basically, if it's a bigram language model, so if it's a bigram language model, then the unique number of bigrams will be the vocab. Okay, so then they will be divided by this thing. So this is the simple kind of smoothing. So that's why, so if this is the case, so then you will always find some kind of probability. Okay, so the probability will never will be 0. Okay, so the probability never will be 0. So you will always get some kind of value. Maybe it's small, but you will get the value. So this is the primary discussion. Now if now calculate the probability of this word with this sentence given the same problem. So now how will you go forward? Let's see. So they're saying, so this is a bigram model. Okay, so they are calculating all the unique bigrams here. So they are calculating all the unique bigrams here. So what are the unique bigrams? So you can see. So this is just to just in the first, I think last 5-6 slides before, I already discussed this kind of thing. So suppose you have a you don't have enough word before a starting symbol, then you can enter some kind of dummy thing. So as it is a bigram thing, so they are just adding extra things. So to for the sake of completion, so it is not necessary, but for the sake of completion, you can add extra word, dummy word. So what kind of different unique bigrams are there? So this is the first one. So you can see there this kind of unique biograms in the corpus. Okay, so the total number of unique biograms is 28. Sorry, the unique biograms is 20. So basically, then what will be the vocab size of this language model? 28, because the 28 different biograms are there. Now you need to calculate the probability of the whole sentence. Now how will you go forward? Now first you need to, as it is a biograph model, so the first thing will be start with, like, given the star symbol and this dummy thing. So just ignore this dummy thing. So given the star symbol, what is the probability is Bob. Okay. So this you can see. So how many times this S happened previously? So for all these 5 sentences S is there. So the count is 5. But we are adding the total number of vocabs also. Okay. So in our case, the total number of unique biograms is 28. So we are adding 28 here. Now given this S, how many times Bob like followed this star symbol? It's only followed once. You can ignore this thing. So yeah, so sorry, this is the separate character. So Bob so this Bob followed star symbol twice. Okay, so this the 4th sentence and 5th sentence. So 2 is here, and we are extra adding 1 because we are going with add 1 Laplace smoothing. So we are adding 1 in the numerator, and the denominator we are adding distinct number of vocabs. Okay, the total number of vocabs in our language. So this way you will find the probability of Bob with this Laplace. Similarly, we will go, if we go forward, we will find each of them. Well, now see the effectiveness of this kind of smoothing. So given this S and Bob, so S and Bob happens twice in this corpus, the 4th sentence and 5th sentence, and you are adding with the total number of vocabs in the denominator. But if you see, so learned, you cannot find the learned anywhere in the corpus. Okay, so you cannot find learned anywhere in the corpus. So basically learned means, so after this S, Bob, then learned. So S, Bob, learned, you will not find anywhere. So basically the probability is 0. But if we don't go with this Laplace smoothing, so the probability will be 0 by 2 and it will be 0. But now as we are going with this Laplace smoothing, it will be 0 plus 1, then 2 plus 1. So this is the usefulness of such kind of smoothing. Okay. Similarly, if we go forward, we will find this. Similarly, yeah, we can again say this kind of thing, signs. Bob learns my signs. This thing is not present in the corpus. Okay. So but as we are going with this kind of smoothing, we are not getting any non-zero, zero value. Okay. Yeah. So we'll end here, and we will get the probability as this thing. Okay. So this is a biograph thing. So the probability is this. So I hope this is clear. So if you have any doubt, you can ask. So I think it is clear till now. If you have any doubt, you can ask in the chat box. I will try to answer this. Okay. Now, the next immediate question is that. So I hope there is no doubt. Okay. So now the immediate question is that, given this biograph model, but without smoothing. So we are not going with the smoothing thing. We are just going with the biograph language model. So this is the biograph language model. Now they are asking, so which sentence has the highest probability estimate? Okay. So which sentence has the highest probability estimate? So there are 4 sentences. They are asking, so given the corpus and the biograph language model without smoothing, which sentence has the highest probability estimate? So if you see the wording, so without smoothing, so that means we are not going with any kind of last move anything. And if we see the 4th, like these 4 options, you don't need to calculate any value. You can just tell without touching the pen. Like you can tell me the, okay, so this sentence is the highest probability one. Just check which like the clue is here, the without smoothing. So we need to check some of the words which are not already exist in the existing corpus. So for that, the whole probability will be 0, because like we are going with this chain rule of multiplication. So if any of the probability is 0, then the whole sentence probability will be 0. So you need to find a sentence for which one of the word is not present in the training corpus. Okay. So let's see one by one. So start with the first sentence. So Michael played at the playground and then stop. Okay. Now check. So is this sentence is possible as per this corpus? So the Michael is there. Yeah. Okay. Played is there. Individual correct. Now, yeah. Add this there. Playground is there. Now just see. So as we are going with this diagram thing. So have you see anywhere like, so if we go this thing, so then you need to have the probability of played given Michael. So this is one of the diagram of this sentence. So probability of played given Michael. But can you find this thing here? So Michael is never followed by played. Sorry, so for played is never followed by the Michael. So yeah. Only once played happened, but it's followed Jack. Okay. So this sentence is not possible. So number A, option A is not possible. I hope you get the logic. Similarly, you will find Bob went to the school. Now see, is it possible or not? Again you can see. Okay. So Bob went. So now this went. Okay. So you need to get the probability of went given Bob. But you cannot find anywhere where went is after Bob in the corpus. So the option B is again out of context. Now if we go to go for C, the school was huge. I hope this sentence is possible. Because you can get the probability of the given S, because in the first sentence you can get the probability. If you have the probability of school given the, yeah, in the first sentence you can have the thing. Probability of was given school, yes, in the first sentence is there. And huge given was, yeah, in the third sentence you can find huge given was. So you will also find the probability of this thing. And the last thing is that given huge, the N tag, you will also find the in the third sentence. So the number C, the option C is possible. Okay, but again, if you go to the option D, you will find a similar situation for which you cannot find the probability. So just check. I think Jack is there. Yeah, the first thing is there. So the probability of Jack given the star symbol, you will never find the probability from here. Okay, so this sentence is also not possible. So only C is possible. So there is no need to check the probability of each of these things. So C is the answer. Yeah, C is the answer. So what is the logic? So you already discussed things. For A, you cannot find played given Michael. For B, it's not possible Owen given Bob. And for D, is not possible given Jack. Given the star symbol, Jack probability. And for only we can find the probability for C. Okay. Okay. So this is the another question. So the question is asking for a corpus MLE, so the maximum likelihood estimate. So for the diagram, so there is a corpus. So they are saying that there is a corpus. In the corpus, there is a diagram called battery life, and its maximum likelihood estimate is 0.27. Okay, so its likelihood estimate is 0.27. Okay. Now, yeah. So now, they are saying that after applying Laplace smoothing, the MLE, the maximum likelihood estimate for the battery life, becomes 0.25. Okay. Now they are asking what is the vocab size of the corpus. So what is the vocab size of the corpus? So this is the question. So I hope the question is clear. Now they are asking to calculate the vocab size. I request you all to try it once. Then we will solve it together. Oh, what is the schedule? Okay, sorry, I have not seen the thing. So you are asking, so what is the schedule of the live sessions? Are this recorded? Yeah, these sessions are recorded. I will upload the session, like this session and the previous session soon, maybe by this weekend. And the timing is that from 6 to 8 every Tuesday, from 6 to 8. Okay, so we'll start from 6. We'll end basically most of the day it's not possible to go till 8, but yeah, so at least it will be 1 hour session. Okay, so it will start from 6 to 8, and my request is that please join on or before 6:05 maybe. Yeah, now see there are people still coming, so this is my request to come on or before 6:05 or 10. Okay, so then it will be helpful, else I need to go again and again, or maybe there are people who will not understand the previous thing. They will ask, okay, so where can we go back? So to avoid confusion, this is my request to come in time. Else you can just see the recordings, but it's always to come in the live session, because we can interact. So if you have any doubt, you can directly ask, so we can clarify. So okay, so let's do the problem. So I hope anyone has done this thing. So if you have anyone have done the problem, can you write the answer in the chat box? Okay, so let me do it. So the question is that they are saying that the diagram battery life ml is 0.27. So the diagram battery life is 0.27. Okay, and the frequency of battery is 8. And the frequency of battery is 800. Okay. Now only from this two thing, what different information can we get? We have the probability of this battery life. Okay, we have the probability of this battery life, and we have the probability frequency of this thing. So what is this thing? So what is this probability tell us? So this probability is basically frequency of battery and frequency of battery life. This is basically 0.27. Now they are saying that frequency of battery is 800. Okay, so from this thing, what we can infer? We can infer that frequency of battery life is 0.27 into 800. Okay, now what they are saying? So they are saying that now they are applying So now they are saying, so they are applying some kind of smoothing, so Laplace smoothing, and after this Laplace smoothing, this ml of battery life becomes 0.025. Now they are asking what is the vocab size. Now they are saying after the this kind of smoothing, now the probability, the previous probability is 0.27. Now I'm just writing it like P star of battery life, just to indicate this is after the smoothing. Okay. Battery life is 0.025. This is 0.025. Now they are asking what is the size of the vocabulary. So they are interested in to know the size of V. Now from this formula, what we can what we do. So what is the thing? So what is the formula of Laplace smoothing? So it's basically, if you can remember, it is basically frequency of battery. So basically, what is the P? What is this thing? So P battery life. What is this? Frequency of battery, and then frequency of battery life. Now, what is Laplace smoothing do? Add one Laplace smoothing do? It is just adding some value here and adding some value here. So they are adding. Suppose they are adding V here. Okay. So they are adding V here. Let me see. So is there any other thing they are asking? No. And there is another thing. So they are just adding something here. Okay. So this is the thing. This is the formula of Laplace smoothing. So we are just adding one here, and we are adding this V here. I'm just assuming. So we are going with add one Laplace smoothing. So that's why we are adding one and adding V here. So and this is basically 0.25. Now we know this value, battery life, frequency of battery life. This is this thing, and we also know this value, 800. So just one unknown is there, and all these things are known. Okay, so all these things are known. So basically, this is 0.027 into 800 plus 1 by 800 plus V into 0 0.0 sorry 0.0 0.025. If we check, we will get the value of V. Okay, get the value of V from this equation. If you see, yeah. So the first thing is that the probability of this maximum estimation given like the estimation of life given battery is a simple thing. So you need to check the frequency of wave. Then same thing, you already know this thing is 0.27. So you just calculate the thing. So battery life. So you'll just calculate the thing. So frequency of battery life is 216. Now you are just using the Laplace smoothing. So the Laplace smoothing is that like the frequency of battery life plus 1 by battery life plus V, and and this new thing is that 0.25. And if you go with this equation, you will find the vocabulary size will be 7880. Okay. So the problem is simple. Okay. So yeah, for this week, this much we can tell. So if we have any other, like if you have any other doubts about the second week thing, I don't know how much. Let me check. So till how much they have taught in the second week. Yeah. Yeah. So till this much only in the second week. So I think we need to stop here. If you don't have any doubt, we can stop here. But if you have any doubt about any question regarding the second week language model thing, you can ask. Okay. Else we will stop. And okay, and I will upload the videos. Like I will upload the videos and these documents, like these slides. So don't worry about that. Yeah. Yeah, please. uh no, basically the thing is that, like, there is no reason. Suppose this thing, so suppose you have this dog and this cat. Okay, so if you go with the substitution, so we are saying, okay, so the cost is 2. So basically, but it's inherently there's a 2 operation. Okay, so one is deletion plus one is insertion. Okay, so you need to delete D, you need to delete D, and then insert C. So basically, inherently it's a like 2 operations. So delete and insertion. So that's why you are just saying it's 2. Okay, so it depends upon the problem to problem. So it's not like that. But from this thing, so if you think like insertion and deletion is 1, then for substitution you can say it's 2. So from that logic, I can say it's 2. Okay. But there are other operations which depends on various issues. So then the cost depends upon the application. But in this regard, so if you asked about this substitution thing, why is 2, then I can say, okay, so like as this insertion and deletion is 1 and 1, so it's cost 1 and this cost is 1, and so this substitution cost is 2 because it's consists of these 2 operations. Is it okay or? Okay, okay. Okay, so if don't have any other doubts, you can ask. Yeah, so you can leave. Yeah, next week we'll discuss about the third week assignment, and yeah, I know. So I think you are already in the third week or fourth week, but we are lagging behind in this discussion session. But that's how this is planned, so I cannot do anything about this thing. Okay. Okay. So what? Let me. I shared a jam file with the meeting. Yeah, but it's access denied. Yeah, they're asking. Okay. Maybe okay. So next from the next meeting, you can send this. We can share. We can use this jam file. Jamboard. Yeah. Yeah. Uh, Basically, frankly speaking, I only followed this book, this Juravsky book. I, I actually, when I take this course, it will be maybe around 5 years back. So I am not sure about now what is the status now. But I don't think you don't need to solve much numericals, because the thing is very simple. If you get the concept, it's not that you need to write like different sentences and you need to calculate the probability. The thing is that you need to like you need to have the knowledge how the things work. So it's good to practice numericals, but it's not that you need to practice day in day out. So just solve one or two problems, just get the idea, and these things. There is no trick in this kind of thing. So you know how to calculate the probability. So given a sentence, calculate use the chain rule, calculate the probability. If you are using a bigram language model, calculate with bigram probability. If you use a trigram language model, with the trigram probability. So it's not like that. You need to like solve many numericals to get used to. Yeah, 2 3 numericals you can do to get like how the formula works and to have a good feel about the thing. But it's not like that you need to practice again and again. But you will find, I think you will find, like if you search with this kind of thing, so this thing, so language model, bigram language model, numericals, I think you will get many PDFs from different universities. So all these universities provide this kind of assignment, so you will find this PDF files online. You can take those PDF files and then and then solve this thing. And the good thing is that most of the PDF files for these assignments will come with their solutions. So you'll also check this thing. So just you need to just search search with some cleverness. Maybe you will search bigram numericals assignment PDF, some kind of thing, and you will find lots of university PDF. So and we can download and check this. I don't know the exercise section of this Juravsky book, uh, but if I don't think there are if there are sufficient problems or not, is there or not. But if you can also check this Juravsky book, but I don't think that is necessary. Like you can find lots of other online material in the web. Yeah, so what you are asking, so is this necessary to use smoothing in the problems finding probability? No. So the thing is that if they in the questions they will explicitly mention, so as use Laplace smoothing or without Laplace smoothing, they will explicitly mention that in the question. So if they mention, then you need to do. If they do not mention anything, then you can do one thing. So if they do not mention anything, just write a assumption. So before solving the thing, just write a assumption. So I am assuming, maybe you are not assuming. So suppose you are assuming you will not do Laplace smoothing. So just write this thing. So I am doing the problem without assuming any smoothing. Then we will do the sum. So in the end of the day, they want to see what is your conception. So it's not like that you need to mark the things and do the thing. So if you assume that there is no Laplace smoothing and you will do the thing according to that, it is perfectly fine. But most of the time in the question they will explicitly mention that in this question use this language model, this bigram language model, this trigram language model, and go with Laplace smoothing or any kind of other smoothing if they are there. So will we get to imply this technique using Python? I hope that I'm not sure. I think they will give you some kind of Jupyter notebook where you can practice and get your hands dirty with the problems. And it necessary, and there is no it's fine to know the theory, do the this some numericals and all these things, but without coding these problems, you will not get the total feeling about all these things. So yeah, I don't know they are providing you the notebooks or not. If they are providing, use this thing, and if they are not providing any notebook, do it yourself. There are plenty online material in the website, in the online. Just go any of just try it out, because without solving coding problem, there is no fun without this thing. So it's always good to have the theory, but practical knowledge is more utmost necessary. So you need to do it. Don't rely on if they will provide you the Jupyter notebook or give you the coding assignment. I don't know, I'm not sure, but take responsibility, do it yourself. And Aviral is raising his hand, so you can ask. Yeah. Yeah, so basically the thing is that frankly speaking, the way this course is designed, it's like teach you the basics of NLPs. Okay, so this Ngram models, and again you will follow all these things. You'll parse tree and all these things. But now recently, I don't know how much you are aware of the NLP literature, but the thing is that now this is the era of deep learning, and I hope you know this GPT, chat GPT, all this thing. Yeah, so those things are now in the full force. So no one nowadays use this kind of this n-gram models, bigram models, but these are the actual concept. Because if you see that how this GPT-3 trained, if you see how BART trained, so those are also language models. So those are also language models. So this concept are like still prevails, but the techniques changes. So if you are just thinking, okay, so I will build a sentiment classifier using this n-gram models and all this thing, I'm not sure. Like you will still get some accuracy, but you have to like you need to use some recent techniques. So you need to use BART. I hope you know BART. BART, BART, BERT, multilingual BART, and all this thing. So you can search in the website. So there are so in the Google. So there are lots of pages you will find. So just search sentiment analysis using BART or using transformers. You will find lots of codes available. But the thing is that if you just take those information and use it, maybe you will fail to learn most of the thing because you don't have a background. Okay, so to build the background, you need to go through the course. So I know. So if you are feeling, oh, it's not helpful now, it's so basic, but this thing will help you to build the basic. So these things are necessary. But yeah, I understand your concern, and it's in somewhat extent is true. But yeah, you need to have some patience to go there. Else you can just download the codes. The codes are already available. So for sentiment analysis, there are n number of codes are available, already available. So it's very simple. So you can download and run it. But no fun in there. So you need to get your hand dirty. So check. So there are multiple steps. You need to check the data, and you need to analyze the data. And there are multiple steps involved in this kind of problems. So it's always better to learn this thing. So linguistic is very necessary. So this NLP thing. Okay. So yeah, I can talk about those things hour and hour. So, but there is no point in that. So if you have any problem about those things, you can contact me. I will help you. So it's not like you will start flooding mail. I'm just saying. Yeah. So I will provide my mail ID maybe someday. You can mail. So which year you are in? Okay. So we're in second year. So yeah. Now you have time. So just read the basics. Don't try to jump step, because like in the in the beginning you will find, okay, this is fun, but at the end you will not understand anything. Okay, so it will, so always start, like, build a good basic. It's very important about your placements. And also basically why you want to do this kind of projects. So you want to put that thing in your resume. Yeah, and in the interview they will ask you questions. But if you don't have the clear basics about all these things, anyway you cannot. So these interviewers are also very smart. So don't think they are doesn't know anything. So they know everything. Okay, so always better to build the basic. Okay. Any other questions? Yeah, someone writes BART. Yeah, Tarun Kumar. So yeah, BART. Yeah, BART. But basically you can read about transformers, so transformer architecture. And the thing is that write code, like, as much as possible. Write main, like, read a topic, try to implement it. So then you will get the idea. Then you will find thing interesting. Read about transformer type of model. Transformer. Okay, so just transformer. So if you search about BART, you will find what is transformer, and okay. then I hope there are no further doubt. Then we can stop it here. Thank you everyone uh, for listening. Okay, goodbye. Goodbye. Thank you.